Hello guys, today we are going to look at the problem called bulls and cows on LeetCode. It is a famous Google question. So the question says, you are playing the following bulls and cows game with your friend. You write down a number and ask your friend to guess what the number is. Each time your friend makes a guess, you provide a hint that indicates how many digits in the said guess matches your secret number exactly in both digit and position, which is called the bulls, and how many digits match the secret number, but the position is wrong, called the cows. So the approach to this question is that we have to compute the bulls first and then the cows later. Why so? I'll give you an example. Assume that this is the actual number 9957 and the guess made is 7997. So if we are computing at the same time, I mean the bulls and the cows at the same time in the same for loop, then here we might compute this 7 as a cow, but in reality it is not a cow, it's a bull, the last two sevens in both the actual number and the guess. So we might, so the actual computation for this problem, for this number, for this problem should be, there are one bull here, one bull here, so two bulls, and we will compute this cow as a single cow, right? But if we are doing the computation in the same for loop for both the bulls and the cows, we might end up doing something like this: two bulls and two cows, which is wrong, right? So let's go ahead and write down the solution for this problem. So first we will initialize our variables for the bulls and the cow, 0. Now we will compute for the bull first. So we'll start iterating over the guess string. So I will enumerate over it. So I will iterate over the index and the value at the same time. So index common num in enumerate guess. We'll check if the number in secret string at this index, not num, index, is exactly this number that we are looking at. Then we have a increment in the bulls. It's a bulls. If it is not exactly the same, then we just continue, right? We have our bulls computed using this for loop. Now we'll go on and compute for the cows. For that, I'll create a counter dictionary for the secret string. So count underscore secret is nothing but secret is nothing but the counter dictionary for the secret string. And now we'll again iterate over the guess string to compute for the cows. So if the num that we see right now is in count secret, it's present in that dictionary, then we just look at the value for that key. So if count secret sub num is greater than 0, then we have an increment in our cows variable, and we have to update the value for this particular key as well. We have to decrement because decrement by 1 because we have already considered it as a single instance of a cow. The else part will be just we continue because it doesn't have the number of instances left to be computed as a cow, right? And the else part for the outer if also needs to be continued. So now you guys will say that, hey, what if now you have actually computed the bulls and the cows again. So we'll just update our cows by removing those bulls. That's it. And what we have to return is the format where we have the bulls count, we have the A for the bulls, then we have the cows count, and we have the B for the cows. Let me go through it again once. We have the bulls and the cows variable initialized. Then we are iterating over the guess string, and we check if the number that we're looking at right now at the exact index, is it the same in secret as well. If it is, then we have our bull computed. Now we create a counter dictionary for the secret string. Now we again start iterating over guess to compute for our cows. If that number is in the counter dictionary for the secret, then we check if the value for that key is greater than 0, then we increment our cow count, and at the same time we have to update the value for that key in the count secret counter dictionary. And after doing for all the numbers in, okay, this should be guess, it should not be counter dictionary. Wait a second, what did I do? No, sorry, I thought it was a for loop. Okay, it should be count secret, sorry. Now we'll update our cows count because it has the bulls count as well computed in it. So we just remove that and we return this string which is required. So let's just run this. Okay, there's a failure because we have bulls instead of bull. We have a success here. Let's submit this. We have a success there. Now, I would like to tell you guys one more way that I actually just realized that we can do instead of this whole if and else here. So what I can do is I can create a counter dictionary for the guess as well. Counter guess, and we should iterate over the count dictionary for the guess and check if that number is in secret. And instead of doing this whole if and else here, what I can do is take the minimum of both the dictionaries for that particular key. So our cows will be the minimum of count secret sub num comma count guess sub num. Let me run this. Success. Let me submit it. Success. So let's discuss the time and space complexity for this solution. Constant time operation. This is big O or big M, whatever notation you want to use, N or M for guess. N or M would be the number of characters in this guess string. Constant time operations. Then these both are big O and big O of N and big O of M. Each of these separately. So right now, till right now, we have big O of N plus big O of M. So big O of N plus M. Here, big O of N or big O of M. And then these are constant time operations. So the whole solution is big O of N plus M. The space would be, we have two counter dictionaries. So big O of N plus M again. And do we have anything else? No. Yep. So both the time and space complexities are the same in this solution, big O of n plus n. Thank you.